Our story begins over 4.5 billion years ago, in a time when the universe was still young and full of potential. Imagine a vast cloud of gas and dust, a nebula drifting through the cosmos, a silent and serene expanse waiting for a spark. This was the raw material for our solar system, a cosmic nursery filled with the building blocks of stars and planets. A disturbance, perhaps from a nearby exploding star, sent shockwaves through this cloud, stirring it into motion. The shockwaves acted like a cosmic sculptor, causing the cloud to collapse in on itself, initiating a process of transformation. Gravity took hold, pulling the gas and dust together, creating a dense core at the heart of the collapsing cloud. The cloud spun faster and faster as it contracted, becoming denser and hotter at its center, a whirlpool of cosmic material. This central region, a fiery ball of hydrogen and helium, eventually ignited into our sun, a new star born from the chaos. The sun's birth marked a pivotal moment, a beacon of light in the darkness of space. It illuminated the surrounding disk of leftover gas and dust, the birthplace of our planets, a swirling disk of potential. Within this disk, tiny particles began to collide and stick together, the first steps in the creation of planets. This process, called accretion, is fundamental to planet formation, a slow but steady gathering of material. Over millions of years, these particles grew from dust grains to pebble-sized objects, then to boulders, each collision adding to their mass, and eventually to kilometer-wide bodies called planetesimals, the building blocks of planets. The early solar system was a chaotic and crowded place, with countless planetesimals zipping around a young sun, each on a path to becoming something greater. Gravity played a crucial role in shaping the destiny of our planet, influencing the formation and evolution of celestial bodies. As planetesimals moved through the protoplanetary disk, their gravitational pull attracted more dust and smaller objects, gradually growing in size. Over time, the largest planetesimals swept up their smaller neighbors, growing larger and larger, eventually becoming the seeds of planets. This process of collision and accretion was like a cosmic game of marbles, with the biggest players eventually dominating the field, shaping the early solar system. In the inner solar system, where Earth was forming, temperatures were relatively high, influencing the materials that could exist there. This meant that the planetesimals in this region were composed mostly of rock and metal, materials that could withstand the intense heat and pressure. As these rocky bodies collided and merged, they formed the building blocks of the terrestrial planets Mercury, Venus, Earth, and Mars, setting the stage for the solar system we know today. The process of planet formation was not without its drama, marked by intense and violent events. Collisions between planetesimals were often catastrophic, releasing enormous amounts of energy and reshaping the surfaces of these young worlds, leaving lasting impacts. It was a time of intense bombardment as the solar system gradually cleared out its debris, paving the way for more stable planetary environments. The scars of this early period are still visible on the heavily cratered surfaces of the Moon and other terrestrial bodies, serving as a testament to the violent origins of our solar system. Imagine the early Earth, a fiery molten ball of rock constantly bombarded by asteroids and comets. These relentless impacts were not just random events, they played a significant role in shaping the planet's future. The energy from these impacts, combined with the heat generated by radioactive decay within Earth's interior, kept the planet in a molten state for millions of years. This intense heat caused widespread volcanic activity, with magma continuously erupting onto the surface. This period of intense heat was crucial for shaping Earth's internal structure. The constant churning and mixing of materials led to the differentiation of the planet's layers. The heavier elements, such as iron and nickel, sank towards the center, forming Earth's core. This process was driven by gravity, pulling the densest materials inward. This core, initially liquid, eventually started to cool and solidify. Over time, the solid inner core formed, surrounded by a still molten outer core. Lighter elements, such as silicon, oxygen, and aluminum, rose to the surface, forming the Earth's crust. This crust was the first solid layer to form, providing a foundation for future geological activity. This process of differentiation, driven by gravity and heat, created the layered structure of Earth that we know today: a solid inner core, a liquid outer core, a viscous mantle, and a thin, rocky crust. Each layer plays a crucial role in the dynamic processes that shape our planet. The early Earth's atmosphere was very different from the one we breathe today. It was a thick, toxic mix of gases, primarily composed of carbon dioxide, water vapor, and nitrogen. It was likely composed mostly of gases released from the planet's interior through volcanic eruptions. These eruptions were frequent and intense, releasing vast amounts of gas into the atmosphere. This early atmosphere lacked free oxygen and would have been toxic to most life forms that we know today. However, it was rich in other gases that would later play a role in the development of life. However, it played a crucial role in trapping heat and allowing liquid water to exist on Earth's surface, setting the stage for the emergence of life. The presence of liquid water was essential for the chemical reactions that would eventually lead to the development of living organisms.